All right, so this is just a short video, just with information for anyone who's going to be running the iHyd script as part of the TNC BRAT project. So there's a page here with some links. So this is on the PyBrat webpage, and if you go to the BRAT help tutorials, I put together this FHC internal page. And this is all pretty like bare bones right now, but the idea with this is that we're gonna have some documentation, like videos and things that we don't necessarily want to host on Git because we don't want them to get kind of buried in everything that's on Git. So we want to house some project specific and lab specific instructions and things on the web page here. So for right now, this is where this FHC internal subpage is, but it might be moved somewhere else. But in here, I threw up this TNC BRAT page. And so as far as the iHyd stuff, I put together a spreadsheet that has the base flow and high flow regression equations. And so that can either be accessed via Google Docs or via Box. And if this page, for whatever reason, like disappears or gets moved and you can't find it, if you go to, this is obviously just for folks in the lab who have access to Box, but if you go to our projects and you go to California, TNC BRAT, working data, there's this project-wide folder, and then there's a discharge folder, and there's this Excel spreadsheet, the iHyd equations. And so if you open that up, whenever you access it, there's 4 different tabs here in the spreadsheet. So there's the equations, so there's the 2-year Q equations, and these come from the USGS technical report, which there's a link to on the PyBrat webpage to that document. Otherwise, again, if this disappears, pretty sure all the techs at this point know, you can just search for stream stats, regression equations, and navigate to the state ones there. But I went ahead and put the equations in here in the spreadsheet, so you shouldn't have to do that. So there's a column for the hydrologic region code, hydrologic region name, and then that Q2 equation. And as far as, the drainage square mile, you guys at this point all know how to, enter these equations into the iHyd Python script. But that precipitation, and it's precipitation in inches. And if there's any of these variables that you're wondering, what does that stand for, you can go to this variable key right here. But with the 2-year Q, there's precipitation in inches. And I actually already went through, because I had this stuff from essentially deriving the base flow equations, and put together this sheet that has for each Huck 8 in the TNC project area has what is the region code. So you'll use that obviously to figure out which equation to use. But then I have in here those basin level variable values. So there's the mean elevation for the basin in feet, the mean percent slope for the basin, and then the mean annual precipitation in inches. So you should not have to go to the stream stats page and have to download this information. It's all right here. And so yeah, that is the Q2 stuff. And for California, unfortunately, the USGS hasn't created any low flow regression equations, and we weren't able to track any down, so we had to generate our own. So if you go to this base flow Q equations sheet, there's for each of the regions. It's organized by region code, region name, and then the month. So this is July, August, September, October, November. And one thing we have to determine is, I'm not sure, I need kind of Wally and or Joe to make a call as to whether you guys should be, essentially for each watershed, if you want to figure out what the low flow month is, or if we just want to, which is how we've tended to do things, or if we just want to across the board say, for the North Coast region, we're going to assume that the low flow month is September, and so we're going to use this September equation for all of the basins that fall within this North Coast hydrologic region. So anyway, that's still to be determined, but at least for now, all of those equations for what are going to be, the most likely low flow month are all up here. A couple of them I left blank, like, the North Coast, it's a rain-dominated area. The low flow month is, not going to be November. And then also you'll see here that there's essentially two different sets of equations. There's this basin-specific variables, and then the site-specific variables. So for now, we're just going to go with these ones here. What this other set is if we want to use actual, I'm calling these site-specific variables. You can also think of them as reach-specific variables. So like, for example, for this elevation, site, and feet, so rather than in these equations here, whenever we have elevation, it's the average elevation for the entire basin. What this value used in these site-specific variable equations is what's the elevation for the reach. And for these, if you were going to calculate that, if you do decide to use instead this other set of equations, the way that I would calculate, what is the elevation for my reach, is in the BRAT table. There's the IGO elevation min and elevation, and then there's also the elevation max fields. I would just average those two, so that's how I would get at the elevation for the site. And then as far as the precip, so this would be what is the precipitation in the site. And also just a note on that too, you'd have to convert that because those fields are in meters, so you'd have to convert that to feet. And then as far as the precipitation, if you're on box in this project wide folder, there's this Prism dataset, and so this is a precipitation raster. It's in millimeters, but what you could do is use this raster. I'd probably just go with the buffer size that we have been using standard kind of in BRAT, which is, you can either do a 30 meter or 100 meter buffer of the reach and then pull off the average value of this raster. But again, this is in millimeters, so you'd have to convert it to inches. So that's probably a little bit in the weeds on that, since I don't think we're actually going to use those equations, but just wanted to at least explain what the difference between those were. And if you are going to use these site specific equations, you can always just get a hold of me too, and we can go over that in a little bit more detail. But anyway, long story short, just go with these ones for now. And I think that's mostly everything to do with the iHyd. But again, if you're running this and you have any questions, just feel free to contact me.